All right, welcome to another Colaberry Data Talent Showcase. All right, this is a special showcase, guys, because it is the last Data Talent Showcase of the year. That's right, we will not be having a Data Talent Showcase in December. We're going to enjoy our holidays, and we're going to pick it back up in January. But I'm happy to report that in January, we will be moving to all machine learning projects. All right, so we're gonna up the game. We have one tonight, but moving forward, that has already been embedded into the makeup of the program now. So we're moving forward with executing machine learning and solving real data science problems. All right, so tonight, let's get this thing started. All right, so here's my agenda. I'm going to do a small intro. Then we're going to introduce our guest judges. Then we're going to introduce the contestants. We're going to let the presenters go. We're going to get feedback from the judges after each person goes. Okay, after we're done, we're going to launch a poll. Okay, and then we're going to see what the judges think. If the people match the judges, okay, and then we're going to wrap this thing up, talk to our presenters, talk to our judges, and we're going to be out of here about 5:30. Okay, so that's an hour and a half. All right, I hope you guys are ready. We got a good one for you tonight. We got three contestants that won the CAP competition earlier this month, and now they are competing for a cash prize. I do know I think it's like $100 for first place. And better than that, bragging rights. I mean, who would not like to say, hey, I won a Data Talent Showcase? So that's what's at stake today. So I hope you guys are excited. But before I get started, I need to feel the energy of the room. So those of you who know what I'm talking about, put your finger in the air. Go ahead. Even if you don't have your camera on, put your finger in the air. All right. Now, I'm going to tell you to take yourself off of mute and give me a whoop whoop. Okay, but I don't want a little whoop whoop. I want a big whoop whoop. Okay, baby's not next to you whoop whoop. All right, you ready? All right, everybody take yourselves off of mute and give me a whoop whoop.
Woof, woof, woof.
Okay, I like that. I like it when I don't have to ask you to do it again. That's perfect, guys. I love it. Let's crank this thing up. We are introducing our guest judges. One looks very familiar, Mr. Robert Lake. Welcome back.
Thanks, Ali. It's good to be back again.
All right, awesome. Tell us a little bit about yourself.
Well, this one's really special to me because this is my specialty. So, yeah, data science seems to be new. I've been doing it for over 25 years. I was doing it before it was called data science. Logistic algorithms and all those fun things, working in supply chain. So it goes back a long way. A lot of the algorithms you'll be using were developed back in the 60s and 70s. It's just we've only now got to the point where we can use really good compute power to take advantage of those. So I'm really excited about that today. What am I doing right now? I moved on from my previous role. I'm now in a process of trying to help get a new startup up and running, and also doing some consultancy. So I'm in the mix. And my favorite pastime right now is building small computer games for my son to teach him reinforcement learning, which is a form of AI.
Awesome. All right, great presentation. Jeffrey.
Glad to be here. I had a bit of an emergency situation, so I'll be back on video in just a few minutes. But I'm currently leading a data migration division for a large consultancy that mostly works with state government. So I'm on the data engineering side. So the team builds the application, and then my team moves the old things from point A to point B with a lot of transformation and analytics and that sort of thing. So I've been in the data engineering space for about 15 years. Before that, I was in finance and accounting. So it's been a very pleasant change. So thank you for having me again.
All right. Well, welcome, guys. There's our crew. They're going to be judging you guys. They're going to be judging after each contestant comes up. And speaking of the contestants, we have three contestants that are going to be presenting their projects, starting with Bryce. Bryce, are you there?
Yes, I am, Ali.
All
How
right,
you
what are you
doing?
going to be presenting for us this evening?
I'm going to be presenting a project about a data warehouse for the city of Seattle collision.
All right, all right. I know Jeff is liking that. We got a data warehousing project, something a little engineer-ish. All right, sounds good. All right, next up, we have Abel. Abel, what are you going to be presenting for us?
Hi, my name is Abel, and I'm going to be presenting global internet usage from 1990 all the way to 2020.
All right, internet usage. We have to have it. All right, and then we have Shalaja. Shalaja, what are you going to be presenting for us?
I'll be presenting optimizing healthcare investment and hospital stay using data science, machine learning.
All right, sounds awesome. Okay. I think that sounds good. Y'all see the lineup? This is gonna be a good one today. All right, so we're gonna start off with Bryce.
The tell for dinner. Julio served that scampi. You got it if you want it. Got it if you want it. Said you got it if you want it. Take my wallet if you want it now. Jump in the Cadillac. Girl, let's put some miles on it.
Hi, before we start, I have a question for you. Raise your hand if you never felt the frustration of being caught in a never-ending traffic jam caused by sudden collision. Or if you never personally experienced this heart-pounding moment where you've been part of this unexpected life-altering event on the road. So according to the National Highway Traffic and Safety Administration, 77% of motorists in the United States will be involved or have been involved at least in one car accident in their lifetime. This is a statistic that really resonates with most of us, if not all of us. So again, I'm Bryce Ate, an ETL developer. So I invite you today to embark with me in a data-driven journey into the bustling street of the city of Seattle. Today, we'll explore a project that will aim to shed the light on an issue that touches our life more than we may realize: traffic collision. We'll delve into the depth of a comprehensive data warehouse designed to uncover insight, pattern, and solution to make the Seattle road safer for everyone. And this will lead me to my problem statement. So the city of Seattle is the main city of the state of Washington with 3.4 million of population. And in 2019, where we're in COVID era, there have been like 11,000 collisions and 26 fatality. So this staggering number kind of raised the flag for the city. So they come up with a solution to try to carve down on those high number of traffic collision and fatality. So they come up with what they call the Vision Zero, which is the city stating goal to eliminate traffic fatalities by the year 2030. So that's where come my project. So I have to propose to the city a repository of data that have all the collision from the year 2024 to the year 2021, so that they can have insight, they can have report to lead the action. So at every given moment, they can assess the action if they're on target to reach the Vision Zero goal, or if they have to make more corrective action. Here's the objective of my project. So the data set, it came from the catalog data, which is a website that have government data set. And then to lead this action, I have 3 KPIs that will lead the analysis to help the city try to assess their goal at every given moment. So the first KPI was the total number of traffic collision. So like every year, they have to see if the number of collision are going down or up, so they can see if they're still on target. And the second KPI is the total number of traffic fatalities. Also to see if the fatalities, the action that they're taking to achieve their goal, have the number of fatalities going down year over year. And then the last one, the third KPI, is the leading cause of contributing factor of accidents. So they have to come up to identify which one of the factor that as the leading that cause accidents. So if they identify this contributing factor, then they can make action to change the trajectory of accident. So here comes my data flow. So the data flow, the data set was first in CSV format, and then for the business, according to the business requirement, I have to use it in JSON. So we convert this CSV file into JSON format, and then from the JSON format, we extract this data into the staging layers, and from the staging layer, going through some transformation, we load the data into the ODS layer, and from the ODS layer, load it in the data warehouse. So before we can move to the data warehouse, the ODS layers will help the city have analysis like into on the fly, if I can say, like in before the end of the year, every month, every week, they can come up with analysis to see if they are on target what comes to reducing the number of collision with fatalities. Then here's the inside of my staging layer. So I have a sequence container and then a SQL tags to truncate my staging table so that I don't have any duplicate when I run my loading every time. So and then inside of my staging, I have the script tags that read all the JSON file and load them into my staging table. Then we move to my dictionary, my ODS layer, which is composed with 4 dictionary table. And then, like I said prior, the ODS layer will help the city have any analysis at every given time. So they can have interactive fact about like find out where are the roads where are more prone to have accident, or where are the day of the week, or where are the part of the city where people are spending more. So having all those information is being available to them through the ODS layer. And then from the ODS layer, I load the data into my dimension table, into the data warehouse. So I have 5 dimension table. We've mentioned the very important daytime dimension. Without it, we cannot have any data warehouse project. So I load the data into my dimension table using the slow merging dimension, the slow changing dimension type 2 using the merge schema. And then from my dimension table, I load my data into my fact table. I have one fact table, which is fact collision. And then I load in using lookup transformation, because all the data into my dimension were data that was clean. So I look up all the key from all the dimension and load the data into my fact table. Here's my data model, which is the star schema, where you can see the fact table in the center of the structure, and then all the 5 dimension table all around my schema. And then here's the overview of my ETL solution, where the 3 layers, the staging layer, the ODS layer, and the data warehouse layer. So from my data warehouse, I was able to come up with some insight into the data. So the good news is that we have a positive insight. So the positive insight, like I said before, the city wants to see is every year the number of collisions are going down or up. So we can see that in 2010, we have the number of collisions from 2009 and 2010 decreased from 8.74%, which was kind of the highest decrease between 2 years. And then also that year, the city have the lowest total collision, which is 11,615 collision. That year too, the number of fatality was the lowest. So this was a good year for the city of Seattle. Unfortunately, yes, the query that we run to have this insight. Unfortunately, we have also some negative insight that we have. So in year 2019, which is the COVID year, we have like 71.43% of increase in the fatalities from the year 2018 to the year 2019. So this raised the red flag for the city. how can we come up from, instead of getting on track to reduce the number of fatalities, the number jumped. So when we look into the data, we realize that this was the highest increase for the past 10 years, despite the fact that on that year, the number of fatalities, the number of collision was the lowest one. So this showed that the correlation between the number of collision and the number of deaths was a little bit off. So we got to deeper in this year to find out what really happened. So that brings me to my suggestion. So again, like I was saying, despite being COVID year in 2019, we realized that in 2019 and 2020, we have like 24 and 20 fatality, which is for the highest since 2010. So looking into this data, we realized that 13 of those 24 fatalities, more than 50% were pedestrian. So to address this issue, one of my suggestions was that the city should have devices that they put at every traffic light that give longer heads up to the pedestrian across the road. And also they have to put no turn on red on all those busiest intersections so that they can give more time to the pedestrian to cross before the car can engage. And also for our third KPI, when we want to find out which one was the most higher risk of causing collision, it was between the data, between the speeding and driving under the influence. So we realized that 500 collision in average a year was due to speeding, and 400 for driver under the influence. So for them to achieve their goal of Vision Zero by the year 2030, the city then should increase the number of safety campaigns that target driver accountability and responsibility. That's the only way, because that's kind of the main cause of collision. So they have to go hard on this cause if they want to carve down the number of collisions that they experiences. Also, city authorities should tailor the strict speed limit enforcement policy on the most accident-prone routes, like, because speed is kind of one of the major causes of accident. So if they, through my data warehouse, they can identify the road that have more accident and then have stricter speeding limit policy on those roads. And finally, while there have been some fluctuation over the year, the overall trend is a decrease in the number of collisions due to driving under influence, with a year-over-year decrease of 57.53% in the year 2020, which is a good news. However, the fact that there are still 190 collisions due to driving under the influence in 2021 suggests that there's still room for improvement. Therefore, implementing a stricter law and regulation, such as increasing penalty for drink driving and lowering the legal blood alcohol limit, could deter individuals from driving under the influence. So this concludes my presentation. Thank you for your attention. And then if you have any questions, I'll be more than welcome to answer them for you. Thank you.
All right, everybody take yourselves off of mute and give them a woo, woo.
Woo,
Woo, woo, woo. All right, Robert.
Hey, thank you. That was very good, Bryce. Unfortunately, you stepped into an area I've worked in for nearly 2.5 years, about 7 years ago. So I know this data set really well. So there's going to be a couple of observations that are going to come from that. But first, to start off with is like presentation nice and clear, nice and clean. I can follow your logic all the way through. So that was really good. The one thing I'd encourage you and everyone to do is, when you're looking for data sets, check your local universities. I don't know if you know that actual Seattle, they actually have a geo database that allows, they use a system called ArcGIS. And what that does is it maps all that information out, and you can actually get the data directly from there, and you can see it mapped out. Now, Not all the licensing allows you to get everything. There is other stuff that you have to pay for underneath. And I know this because I worked with a car insurance firm for a while, and I did a lot of that work for them. Okay, but those are good things to compare and contrast, because I'm going to ask you some I'm going to pose some questions. You don't have to answer them now, but think about these when you go through. Is I like what you've done. I like where you're setting this, where it's going. You're going to talk about building this warehouse, and the whole thing is three things always come with warehouses: is the source. What is your source of data? Where that data really coming from? The true source of it. And normally with this type of data, it comes from two sources: the police report itself, which is online, and also the civilian independent reports that come through that never went through the police, even though they really should go through the police for insurance purposes. So those are the two main sources that come through. And then who are the consumers of that data? Because one of the things you want to think about is, yes, I can show this information, and if they set this up and pay, you know, $20, $30, $40, $100,000, $300,000, $500,000 to set this system up, is how to recruit that money back. So the other thing to think about is who can consume this. And this is a big part for all analytics today. It's not just the fact that you can report something, is someone else interested in that data? And if they are, how much they're willing to pay for it. Now, I know, because I've done this, and this was about 7 years ago, that an attorney will pay $1 per record for all new accidents that happened in the last 48 hours. Okay, so if you think about it, that starts adding up. I don't want to have more accidents so we can sell more out to these attorneys, but these are things that you start thinking about when you start to talk to people in this area. So that's something for you to consider. And then obviously your warehouse design, I know you designed it the way you did, is a little bit more digging around what Seattle actually does. You'll see that they are more into the graphing side, because it makes it easier to put it onto maps and other pieces. So when you designed your layout, which I liked, you could have used some of those addresses to start pulling out the GIS information. In other words, you know, can I do a lookup on the address to get the Latin long, and then be able to map that onto a map? And the visual maps show much more information. And it's really interesting because, you know, where are these deaths? Are they in a particular crossroad section or particular multiplicity, or is it all over the place, or is it particular roads? Because those things, you can show those things really well, very quickly. It gets people attention. Because sometimes they say, well, what is 300 deaths? Well, if you show, you know, 300 deaths, and by the way, 90% of them are on this junction of this main road, and they happen between these hours. That is such compelling information you can give over. Okay. And then the final thing to add is think about additional data you want to bring in. What other additional data can you bring in to tie to it? Weather data is classic. I know it sort of says in the reports, tries to tell you what the weather was at the time, but can you prove it with historical data? Can you get the similar data around speeding offenses and also DUIs? And my last piece for you is around DUIs. Be careful around DUIs, because there's those who've been caught and those who haven't, and those who have been caught haven't necessarily been in an accident. So trying to get the causal there, just because, you know, DUIs, or people had collisions with DUIs maybe down, but DUI actually may be actually increasing. It's just by the grace of someone, God, Jesus, whoever out there, that you haven't had that many more fatalities. And sometimes that comes misleading, so you have to be careful. This is where lies, statistics, and damn lies come from, is that you can mislead people sometimes. Like, yeah, look, it's going down, but actually on the back end, it's rising. And then the pull through of that will cause a sudden rise. But overall, I really liked it. Just have a little bit more look out there for different data sets and stuff like that. Great job, man. Well done.
All right.
Thank you for your insight.
Feedback. All right, great feedback, Robert. Jeff?
So I did like the presentation, and I like the order, and many of the slides, I did like that there were only a few pieces of information on there, like the KPI 1, KPI 2, KPI 3. You did a very good job of the classic presentation of tell me what you're going to tell me, and then you came to the conclusion at the end. A piece of feedback about the concluding slide with all of the information that had 4 points and the summary at the bottom. I think that could have been split up into several different slides, one at a time. So point 1, point 2, point 3, and point 4, and then the conclusion on a 5th slide, with having the words
and the numbers all together, it was a lot to try to absorb and read at once. And another thing I thought is maybe more related to how you take this into job interviews going forward. You did a great job telling the story to a technical audience. We knew all the, for this audience, the presentation was appropriate. Think about how you could also tell this story to your grandmother or your mother or your, someone in your family that's not technical. How do you talk about what you do and explain that it's not computers? You're saying this is what I studied. I looked at statistics, crashes, and fatalities in the state of Seattle, and what I do is I help them make policies and give them accurate information. So you can tell that story in a job interview. That might also help your presentations if you lead with something very non-technical and don't use any jargon, because you might have a mixed audience, right? Nothing about ETLs, schemas, ODS and those things. If your presentation can start with that and some of your conclusion slides may have that, I think that would improve it a bit. But it's also going to be very necessary in the job interview process, because you're going to have a mixed bag of technical people you interview with, and then you're going to have some people that are non-technical, and you have to tell them how you help the city of Seattle rather than, how you set up a star schema. So I hope that helps.
Thank you. It does. Thank you.
Thanks.
All right. Great feedback, Jeff. All right, let's keep it moving, guys. We're on to our second contestant, Abel. So after I play some music, it's all yours.
Shine bright like a diamond. Shine bright like a diamond. Fine light in the beautiful sea. I chose to be happy. You and I, we're like diamonds in the sky. You're a shooting star, I see, a vision of ecstasy. When you hold me, I'm alive. We're like diamonds in the sky. I knew that we'd become.
Analyzing the evolution of the internet usage from 1990 all the way to 2020 by myself, Abel Kirui. When we think of the internet, we often envision Google, Gmail, Wikipedia, or even YouTube for some of us. But have you ever wondered how the internet came into existence, how rapidly it evolved over the different years, and more importantly, how can we change it or improve it so that it's more accessible and affordable for people around the globe? The internet's remarkable expansion from 1990 to 2020, marked by a staggering 45% increase over the different years, has brought a very big difference on how we take information, how we consume it, how businesses operate, and even how we communicate with different people. But there's an issue that occurs when this happens. Only 59% of internet users, or only 59 people in the globe, had internet access back in 2020. Now, here is my data set. When working with this project, I found myself with only one set of a table, but I had to create other table that would connect to the main table so that I could have an easier time when working with this project. In the top left, we have measuring/DAX, which showcases different measures that I created when working with this project. In the top right, we have refresh date, which shows when the data was last refreshed. In the bottom right, we have a calendar, which shows the different dates I have in my data set specifically. And then in the bottom left, we have country, which showcases the different countries that I had. In this case, it was the whole globe. And then in the center, we have the main data set, which is global internet usage. Let's talk about the different type of KPIs that I had with my project. What is a KPI, you may ask? A KPI is a quick way to showcase a whole data set without having to go into the nitty-gritty. So you could show some few numbers, but be able to explain what's going on in that specific data set. As you can see, I have 4 different types of KPIs, in which we have total internet usage, which goes into internet usage, showcasing all the different types of internet usage from 1990 all the way to 2020. Next, we have new yearly users, which showcases the average of the total users. So in this case, we have 7.5, which shows that between 1990 all the way to 2020, we had an average of 7.5 million users over the different years across the different countries. Next, we have cellular subscription, which showcases the average of cellular subscription for every 100 people around the world. In this case, we had an average of 53 for every 100 people. And then last but not least, we have broadband subscription. In this case, it's a percentage because it's being compared to cellular subscription. So in this case, we could see that we have 53 cellular subscription, but only 11% of those 53 had broadband subscription. When working on any project, you'll always find yourself running into different kind of blocks, finding yourself running into issues. The three main issues that I had was data sourcing, KPI selection, and last but not least, data visualizations. Let's start with the first one, data sourcing. Finding a data set that no one else has ever done when working with their projects, or something that also resonates with me as someone who uses the internet very much. This was a perfect data set for me to work on and also understand where the type of internet that I'll be using when play video games and stuff like that comes from and learn more about it. KPI selection. Even though I might have the best data set, but I cannot showcase this data set in a simpler way for people to understand what's going on, then the data set is not really worth it. So finding the perfect KPIs to showcase this data set was also hard. Last but not least is data visualization. Having the best KPI, having the best data set, but you cannot showcase what's going on in that specific data set in the nitty-gritty can deem that project useless. So let's go into the main dashboard that I created. In this case, we have global internet usage from 1990. In the top right, we have the slicer, which allows you to look at specific time frame in this data set. As you can see, I could scroll through and be able to look at different years in this specific data set. As you can see, 2002 all the way to 2020 can allow us to look at the different time frame. So as you can see, we have the different data, we have the different decades, we have the different continents, and then under that, we also have different countries. In the bottom left chart, we have users compared to country, and then we have users compared to continent and country as a map so that you can understand what's going on. And then in the left, we have the different KPIs that I talked about. We have the internet usage, which shows the total amount of internet users. And then close to that, we have new yearly users showcasing the average. And then we have cellular subscription. And then last but not least, we have broadband subscription. When working with this project, I found myself finding some interesting data. Some were good and some were bad. Let's start with some of the positive ones. In Europe specifically, if we're to look at Europe, the continent, we could look at back in 1990, back in 1998, we had an increase of 72% in internet usage growth. So if we're to look at 1998 specifically in Europe, it went from 1.04 million users to 1.79 million users, growing by a 72% rate. Another one that I found was the internet usage as a globe. So everyone in the world using the internet at the same time. If we're to look at the globe specifically, back in 1993, we had only 50,000 people on average using the internet across the globe, which was a 45% increase compared to the previous year. If we're to look at 1994 across the globe, we had 102,000 people use it, which is a double compared to the previous year. The previous year was only 50,000, but in this year, we had 102,000 people using the internet, which was a growth of 105%, as you can see here in the sub KPI. Of course, when working with this project, I also found myself looking at some negatives. If we're to look at 2020 compared to 2019, specifically in the continent of Asian continent, if we're to look at that, Asian countries had a very big difference when it came to 2019 and 2020, which showcases that COVID really affected how much people were willing to pay for their cellular subscriptions. If we're to look at cellular subscription, we had 120 across Asian countries across this specific decade. But if we're to look at 2019, we had 131 people with a growth of 2% compared to 2018. If we're to look at 2020, it had dropped by 3% to 127. You might be asking yourself, we are comparing this to 100 people. Why is it 127, which is over than 100? Which means that more people or some people had more than one cellular subscription. I might have 2, someone else might have 3, some people might even have 10 as a family or something like that's going on. So as you can look at Asia specifically, this is the country or the continent that mostly got hit with COVID, meaning that people were less paying for their cellular subscription or they were unable to pay for it or they did not really need it as much, which led to a drop of 3%. Another negative insight was back in 2015, specifically in the continent of Africa. In 2015, 103 subscriptions. Even though it's still over the 100, that means that some people had more than one cellular subscription. As you can see, it grew by 3% from 2014 to 2015. But if we're to go into 2016, we could see that it dropped by a little bit. If I was to go back into 2015, you could see it grow by 5% from 2014 to 2016, in which had 85 in 2015. But in 2016, in Africa specifically, it dropped by 2% from 85 to 84. Remember, this is average across the whole country or across the whole continent of Africa, dropping from 85 on average to 84. So with that being said, as I talked about before, how can we improve the internet usage across the globe so that it's more accessible to more people? Number one is enhancing mobile connectivity. We should make mobile phones work better in places that are still developing, like the continent of Africa, the continent of Oceania, where there are only 34% of smartphones for every 100 people on average between 1990 to 2020, in which is very bad compared to some big countries or some big continents like North America, which had a higher number of internet users or cellular subscriptions over the different years. This may really import or create jobs for more people, improving education or even healthcare across the different continent. And then last but not least is bridging rural versus urban areas. The digital divide is a very big gap between these two. If we're to look at rural areas, it's only 901,000 people having internet compared to big cities where 86 million people on average were having internet users, which showcases that there's a very big difference when we create new technologies. When something new usually comes out, you'd realize that countries like North America or continents like North America would be the first one to find it. But if you're to look at other countries like maybe South America may not be getting it, maybe 10 years later, that's when they might get it. So if we're to look at a country like China in the specific continent of Asia, China had an average of 86 million users, but the countries near it had an average of only 32 million people using it. Even though it's just one country, it's still having a higher chance of getting the new technology compared to other countries. With that being said, again, my name is Abel Kirui. Thank you for listening.
All right, everybody take yourselves off of mute and give them a woo, woo, woo. All right, Jeff, we're going to start with you this time.
I really like that presentation. I thought it was just the right amount of information on the page. I like that you had the policy at the beginning and the recommendations, and you went right back to them at the conclusion. This is what I recommend we do. I think that when you're telling a story with data, whether your recommendations are right or wrong, and to some degree, it's important that you take a stand and you have an opinion. You can be wrong and still tell the story and make a recommendation, and it can be a good conversation starter. And you can say, I believe this is the case. I think this is the cause, and this is what I recommend, which is what you did. We need to have more global access, more connections for rural areas. You have facts, and then you have your recommendations. Your facts are correct. Your recommendations are your own and your own opinion. And even if they're not perfect, they're a great conversation starter. And so I like that you took a stand and you had strong recommendations. Where I thought you could improve a little bit was with the interactive screen. I think that you could show fewer statistics and go a little bit slower. So I do like the fast rate of presentation. I think it's a sign of intelligence when somebody speaks very quickly. So it's good for this audience. You may want to consider with other audiences, slowing down your rate of speech and giving them a little more time to absorb the information. It was fast to watch it go on the screen. Overall, it was great. I loved the style and mostly the limited amount of information on a page. It's enough to digest. When you have too many things on a page, the audience tends to read ahead and they don't follow along with what you want. When you give them one piece of information with one or two numbers on a slide at a time, they can keep up with you. And so I really, really like that. That was great. Excellent style. Thank you very much.
Thank you.
All right, awesome. Robert?
That's great feedback, and I'm going to echo that. You are a very good storyteller. And I really like that. And Jeff's right, by the way. It doesn't matter if you're wrong. And this is for everyone. It doesn't matter if your conclusion is seen wrong by the person receiving it. Be proud of what you've done. Set your position in ground. It's a conversation point. The one thing that I'm constantly coaching data scientists and analysts on throughout my career is it's not always your job to make the decision. You're bringing this information to a decision maker for them to start thinking about whether I should make a decision or not. And you may be completely polar opposite, whether it's political, sociological, whatever. It doesn't matter. It's a conversation starter. Okay, and that's a really important thing. Now, for me, let me help you tie this up a little bit, because going through, I could follow what you were saying, but you were mixing different areas of what we call a PEST lead analysis. PEST lead is political, economic, sociological, technology, legal, international, environmental, and demographic. That's a big mouthful. Basically, it's a marketing way of splitting something up, especially when you're looking at worldwide or even region-wide, how to split it up by its different components. And you had them all in there. So the one thing I would like to see a little bit more from you is a little bit more history. For example, from let's take a societal piece. If I go back, it's must be 15, nearly 16 years ago now, we had, out of MIT, was an initiative called the Child's Machine. This was trying to generate the $100 laptop for children from Africa and other underserved places, to be able to build a laptop cheaply and effectively without compromising on what it is, so they could have access to that. Because one of the biggest environmental and demographic disadvantage of not having good access to the internet is education. And that's in the US, that's in Europe, and that's even more in some of these lesser developed countries. Okay. And so using the PEST lead framework would help you say, this is more from a political point of view, this is more from an economic point of view. And you had those points in there. What it would have helped from a business leader's point of view to understand when you're switching from one to the other. Otherwise, they may be going, okay, where are you going with this? Are we going political? Are we going economic? Where are you going on that? Okay. A couple of things on there, especially around technology. Think about technology. You had a beautiful slide up showing that expansion. In 1999, I joined Cisco Systems just before the voice of IP kicked in. And I remember when I joined them, I was being laughed at. I was like, why do you want to join them? They're the crazy people that think they're going to put voice over data, where we were putting data over voice. What happened within the next 6 months, coming out at the end of 1999 into that, we had what we call the internet boom. Voice over IP took over. A lot of the big baby bells went they tanked badly because they were way behind it, didn't think it was going to happen. Then video came. And that really drove those things. And then you start seeing all the political stuff kick in about laws, about, no child left behind, minimum education standards for children, minimum exam standards, minimum access to internet, and all these other things start coming through. So that started to drive that. So that's part of those. And the other one line on the thing in there, which most people want to acknowledge, the biggest driver of the internet boom is one thing: pornography. It's the one reason that causes all the spam. It's one reason that causes a lot of the hacking, but it's the one thing that drove video usage and everything else is pornography. So unfortunately, people don't touch on that, but it used to be that 90%. It's probably down to about 70+% now, but it's still a major driver. So there is that thing to take care of, as well as understanding that. But overall, I like what it is. I'm going to put in your comments the PEST lead piece. Go look it up, think about it. And if you look at where you're presenting, you'll go, oh, this slide was a political slide. This slide was a more economic slide. And it would just help with this stakeholder, especially if they thought you were bouncing around a little bit, trying to follow where you're going. But overall, amazing storyteller. I love that. I could have sat and listened to that for a couple more hours.
Yeah, thank you.
Okay, great. 2 down, 1 to go. We got Shalaja going up next. She will be our last contestant of the evening. And then we're going to get the judges, and we're going to get some more feedback from the judges. We're going to vote. We're going to look to see if our judges agree with our vote. Okay, so stay tuned. Shalaja, after I finish playing the music, it's all yours.
Strumming my pain with his fingers, singing my life with his words, killing me softly with his song, killing me softly with his song, telling my whole life with his words, killing me softly with his song.
Good evening, everyone. I'm Shailaja Ranganathan. I'm a data scientist and Power BI developer. Today, I'll be presenting our project on optimizing healthcare resource allocation study using data science, machine learning, and we use this in our Power BI. Global life expectancy has improved significantly in recent decades. It's around 73 years. It has been increased by more than 6 years between 2000 and 2019. As the years progress, we see the average life expectancy increases. This is due to better access to healthcare, shorter hospital stay, and overall advancement in healthcare, leading to a longer and healthier life. In the healthcare industry, hospitals and medical facilities invest in various equipment to enhance the patient care, and this affects the length of patient stay in the hospital. As these investments influence hospital stays, patients experience reduced cost and hospitals can admit more individuals, expanding the access to the healthcare. In an era where healthcare is vital, we are using data science to understand how MRI units, CT scanners, and hospital beds affect hospital stays. Our goal is to create a predictive model to reduce the hospital stay and optimize resource allocation using data from 32 different countries and over the span of years. Why we need to use the data science? That helps us to plan for the resources, how many CT scans are necessary, how many MRI units are necessary to minimize the hospital stay. Then patient flow optimization to reduce the wait time for the patients. The number of patients coming in, if they go out, we can admit more patients in the hospital. And cost efficiency. Cost efficiency is very important. It not only says about the cost incurred for investment in healthcare equipments, but the cost incurred by the patients to stay in the hospital. Imagine if the hospital stay is more, what happens? The patients have to pay more bills, and this is going to affect the humanity. Normal person will get affected. Here you can see a table which shows the average cost of hospital stay per capita in selected countries in 2022. The actual cost of hospital stay may vary depending on several factors like type of the treatment, duration of the stay, and location of the hospital. Here you can see US has the highest per capita cost for the hospital stay, whereas India has the least. Now, we took this data set, healthcare investment, for our data science process. We used it in our Microsoft Fabric, where we created a lakehouse, we created a workspace. What is this data science? Why we need it? First, data science, we are going to identify the problem we have in our data. See, what is the problem? How my independent variables, that is, how my CT scan, MRI, hospital beds, how they are going to affect the hospital stay, right? This is our basic problem. Then in data science process, we read this data, we use some data manipulation libraries like pandas and Python. Then we do the data cleansing to change some values, changing nulls to zeros, do some transformation in Python. Then we are going to train the model. Train the model is predict the best model. Let's see about it. First, what we did is in the notebook, we created some codes where we did the transformation where the string value of our location column is converted to machine language. The data which we got was not clean, so we need to do some cleaning stuff, which we did in Python and in Data Wrangler. In Data Wrangler, we changed the nulls to zeros in Wrangler, and we created some year-over-year columns, which we need to use the first year-over-year as 0. So we did all these manipulation in the Data Wrangler. Data Wrangler is something which is similar to, say, Power Query Editor, where you can clean the data. Here we did that, but for using the Data Wrangler, it is necessary that it should be accessible in the Panda library. So after doing the transformation, then we need to do the prediction. What is the prediction? Suppose, for example, I want to go to a destination, right? What I do, I ask my bunch of friends, hey, which is the what destination you went last year? Egypt, Europe, which one is the best? They all will give their opinion. I will take into account all their opinion and come into a prediction. Like that, this data set, I'll pass it into this data set is split into training and testing. 80% of the data goes for testing, 20% is going for training. To predict the model, what I'm predicting to predict hospital efficiency using the hospital stay as target and MRI, CT scan, hospital beds, all as my predictors. We tried various models, but we got a perfect result which is closer to 1 using our random forest regressor model. This is similar to what example I told. Here it uses multiple decision tree, comes up with a good prediction, and then it gives the average prediction. So when making the decision, each decision tree will give its own prediction. Now, this file is then loaded as Pickle library in our train model. Then what we did is we created a bar chart to indicate which parameters is going to get affected the most. That is CT scanner, MRI, hospital bed, which factor is going to influence my hospital stay the most. We found a conclusion using this bar chart, and we found that the CT scanners play a vital role. That is, they influence us more for the hospital stay. After using this, we had a final file which had our predicted hospital stay. So what we did, we merged that with the source file and then we plugged it in Power BI. So in Power BI, we already have the visualization for MRI, all that. We included our predicted hospital stay, predict how it can decrease or increase the hospital stay. So here, before going to my dashboard, investment in this CT scanner, MRI, hospital beds, they can significantly impact the patient's hospital stay because they may be faster and they can lead to quicker treatment. But there are other factors to be considered. Severity of the illness, patient's overall health condition, available of post-discharge care, hospital policies, they also influence the length of patient stay. Let's go to my dashboard to see that. Here, okay. So in this dashboard, we have used the predicted hospital stay. The file, we have merged our final file from the data science to the source file, and then we plugged it in our RBI. Here, if you can see, from the year 2003 to 2018, we find that the hospital stay is nearly constant, like 6.66, 66 to 7. You can see that it is nearly constant, right? 6.5, 6.4, all that from the year 2003 to 2018. That is, there is some steady improvement in the hospital equipments and healthcare facilities. Here, let's go to some location to see about it. When we drill down to, say, East Asia, I'm drilling down to East Asia location, you can see that in East Asia. So if I see for the year 2010, you can see there is a massive increase in our healthcare investment for MRI, CT scan, and hospital beds, right? And we can see the predicted hospital stay has come down from the main hospital stay, that is to 59%. when we compare to the previous year, we can see that, one second. When we compare it to the previous year, we can see there was not much investment in the MRI, CT scan, all that. Similarly, if we see for the other year, say 2014, there is again a massive increase in the MRI, CT scan and hospital beds. And my predicted hospital stay has come down from the hospital stay, that is to 53%. Let's go to some other location. Here, if we go back to, say, North America, where we have USA and Canada. So let me go to the North America. Here, you can see that in 2004, there was a decrease in the investment, right? It comes down. In my predicted hospital stay, it has increased 7.56. It has increased 5% from my hospital stay. But if we go to 2006, we can see all my investments has come up. There is a massive increase in the investment. Yes, even there is a massive increase in the investment. And here my prediction value also goes higher. It has increased to 12%. And these are some of the insights. And one of the other insight which we found it, like Turkey is the Turkey. Here, if we see, the hospital stay is very less. Hospital stay is very less when compared to the other countries. So why it may be? Because in Turkey, there is something called a post-discharge support is more in those countries. So the readmission of the patient, it will be delayed, right? So we can use these, other countries can have brainstorming these ideas and they can share knowledge for this. So let me go to the next one. So overall, this project, this focuses on the key insights and suggestions which can be given to the healthcare consultants and healthcare managements. This will enable them to make data-driven decisions for resource allocation, strategy planning, and optimizing the patient care. That is, it will be used for proactive decisions for future investment, to implement targeted intervention. Like there are some medical condition or procedure that may take longer time, say for CT scan, it may take longer time or something like that. Then these interventions can be addressed. Patient flow can be managed. We can implement the measures to reduce the wait time. Like they can have an online appointment scheduling, automated alerts, all that. Then more importantly, if we see the Japan, it has the high hospital stay. This is because in Japan, we have old population, it is more. So what we can do, we can promote preventive healthcare. We can encourage regular health checkup, early detection of diseases. All that will improve the healthcare, patient care. As I mentioned at the outset, an efficient hospital system will minimize the hospital stay and optimize the resources. This is a gift which we are going to give to our future generation, offering them more quality time and give a healthier and happier world. Thank you.
All right, everybody take yourselves off of mute and give her a woo, woo.
Woohoo!
All right, Robert, what's your feedback?
Yeah. Okay. So nice and clean and clear. I can follow where we're going through. This is for everyone. Please, please, please. And I tell you this because I'm guilty of this when people probe them up. Never, never, never show your code on a screen. Because you've got people like me going up there, yeah, that line, no, I don't agree with that line. That's not the right place to put that line, and that's not the right way to write that variable. And people will get distracted. Please never, never, never. If someone wants to see your code, you can say, yes, if you have security access to get to our GitHub, you may go and look at it now. Please never share your code. Even when I've done demos with developers, never put code up on a slide, because I guarantee you someone's going to go, that's not the way we format our code in this company. That's not the way you're supposed to do it here. If you did that, you'll just drive yourself down there. So please, I understand what you're trying to do. Try not to show code, because it doesn't matter. And I guarantee you there will be a lot more people in there trying to work out the reverse engineer your code and wonder why your code doesn't do what they would do. And it doesn't matter what level, even at my level now, I still code. And as soon as someone shows me code, it's like a cat with a little laser light. I'm like, ooh, 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 code. And I actually missed those 2 slides, the presentation, because I got immediately attracted to the code and I had to force myself back to listen to the presentation. So just be careful of that, okay? That's
I just used the part of the code actually. Yeah, I didn't show the full.
So let me go back to the data science. Congratulations, your first one to do data science. Okay, so this is going to be feedback for everyone going through. There are 4 things I like to see when someone gives a data science presentation. And I understand what you're trying to do. You're trying to walk people through the steps. There are 4 summary reports I like to get out. And they really come down to 4 things. The EDA, so that's the raw data assessment. You put a nice graph up there and you showed all the big spenders and all the little spenders. But what I couldn't compare and contrast is the distribution. Is the distribution across days the same? Doesn't matter how much on average you spend. Is the distribution of how long you stay roughly the same? Or, do they say only $200 worth in India because they only spend 2 hours in the hospital and they're being rushed out because no one wants to stay in hospital because it's going to cost them an arm and a leg because there's no private or they have to all pay privately or publicly paid. I don't know. So I'd like to see those. Some of the EDA you did there, really important. Your feature selection, you started doing it, but the first question I have when I look at MRI and CT and bed, are they related? So are they truly independent?
I told independent. They are independent.
Okay, yeah. So that's something, especially when you're big predictors, just show, look, they're not independent. They are independent of each other, so we're good. Because the first thing I say, well, wait a minute. I've been in the hospital. I've had a few concussions. First thing is a CT scan. Well, first thing they do an echo scan, then they do a CT scan and maybe do an MRI or maybe in different order. But it's one progression to the next progression to the next progression. So what is that? Just to understand what that is. To come on there. Now, I must admit, you lost me, and it takes a lot to get me lost. And where is it? Yeah, the hospital stay analysis. Script it, keep it short, because you started talking and I'm like, wait a minute, because I didn't see the country on there and I was trying to go back, well, which country is that? What we're doing? I see Japan's name popping up at the bottom. I honestly got a little lost. And if I get lost, there's a problem, because normally I'm the one that the other execs bring in to sit there and say, listen to this presentation, it's going to be really technical, and I can follow it all the way to the end. I did get lost, I'll be honest. I think it was too much. Break it down to smaller samples and just do a little bit more summary. It's nice to play with the sliders, but the trouble is, again, I got a little bit like a cat with a laser pen, and I was like, ooh, is she going to push that slider again? Which slide is this? Okay. And this comes back to feedback I gave in my first one as well. Do some history checks. What happened in the US in 2006? Does anyone know, healthcare wise? If you go online, and you'll find it real quickly. Medicare Part D changes came out. 2 years before that, there was a massive slowdown in prescription expenditure, and then they did a change like that. And I bet you'll find later on. I'm glad you didn't get caught up in the COVID period, because that would have really messed things up. The other thing as well, we had lots of different bird flus and all sorts of different things going on beyond 2006. So there's lots of weird reasons why people would be in and out of hospital. So those sorts of things can mess you up. So just be careful of those things. Just do a little history check. The good thing about the US, a lot of it's online. If it's not online under the government agencies, it will be online in some of the research schools, because there's always someone who's done a PhD somewhere on something, and they will have some of those things in there. So just be aware of some of those things, and just go back and help. It's not so much fact checking yourself, it's just bringing extra information. And you can, and what I would have done is say, here in 2006 we see these go up. I don't know if it's related to this, but there was a big change in the Part D, because I guarantee you someone at that point had an elderly parent, or they may be elderly themselves during that period of time, and they come to the end of their career now. They go, yeah, I know what it was, and we've got these changes to Part D on our Medicare, not happy with it. And now what happens, because you never mentioned it, you take them down a rat hole. You say, because you can really paraphrase it. I don't know if it's related to this, but it's a possible indicator of what was going on at the time in the US. Okay. Overall, I followed where you were going. I did get myself back on track. Just be careful as technical people. Just remember cats, laser pen, not good. Okay. But overall, I liked what you did. Got loads of feedback on the data science side, but that will take me way too long to go through that. But otherwise, well done. Thank you.
Thank you.
Okay,
I'll
awesome.
take your feedback. Thank you so much.
Jeff.
The code off the page, taking those and splitting them up into different slides where it's one piece of information at a time. Oftentimes less is more when you're presenting. And it just like the code distracts, so does too much information on the page. I did like this pace of speaking. It was quite easy to follow. I think with the interactive screen, again, it didn't seem like there was much of a clear pattern. So it was a lot of information very fast. And I think perhaps sometimes with interactive things, I've seen presentations or I've toggled between things that are static and screen grabbed on the slide. And then sometimes I'll toggle back into an interactive piece. So the interactive things, I think with the right audience can be very effective. Sometimes you can show 3 or 4 stats that are screen grabbed and static, and then go back to the interactive piece to show that there's a lot more. Like, these are my main points, point 1, point 2, point 3, point 4, one slide on each. These are the stats. Now I can give you this information. I'm going to advocate that you make data-driven decisions. Here's the interactive tool that if you don't like my 4 stats, you can go and create your own with this interactive tool. So a combination of static grabs plus the interactive tool, I think, would be the best point of storytelling. But it reminded me very much, it was good of an advocacy presentation for making data-driven decisions over making static decisions. So I think it would be very good for the right audience. And I think if you're talking to hospitals and healthcare, you have a lot of people who are, with science backgrounds that would be able to follow a lot of this. So overall, good pace. I think, again, I like the style. A little bit of splitting it up into multiple slides. Generally, I think that's better because you can take 2 minutes to go through 4 points on one slide, or you can take 2 minutes to go through 4 points on 4 different slides. One of them will keep the audience where you want them. The other method will allow the audience to see everything and they'll get ahead of you, just like they will when they see code. So overall, very good. Thanks.
Sure. I'll use this feedback. Thank you so much.
You're welcome.
All right, there we go. I hope you guys are ready for the vote. We are now getting the vote in. Everybody gets to vote on your top person. All right, let's get our theme music going. And all right, the voting. All right, I am ending the poll. All right, we have Bryce with an overall 6.2, originality and creativity 6.5, neatness 5.5, organization 7.0, knowledge and materials 6.0, presentation 6.0. All right, next up we have Abel with a 7.9, 7.5 originality and creativity, 8.0 neatness, 7.5 organization, knowledge and material, 7.5 presentation, 9.0. All right, so if Shalaja, we're looking for Shalaja, can she get above a 7.9? If not, Abel is the winner. If she is the winner. Let's see. 7.2. All right, second place. 7.5 originality and creativity. 6.5 neatness. 7.0 organization. 7.9 knowledge and material. 7.5 knowledge and material. 7.5 presentation. All right, so you see our 3 scores there. We have our winner, Abel, with 7.9, followed by Shalaja at 7.2, And then we have Bryce at a 6.2. All right. Now we need to figure out, do our audience agree? Yes, they do. The audience agrees with the guest judges. They both have Abel in first, followed by Salaja, followed by Bryce. Awesome, guys. Tell us what you did before Colaberry and what was it like preparing for this presentation?
Before Colaberry, I'm still working as a accountant associate. Working this presentation was a little bit nerve-wracking because you wanted to put your best foot forward and try to tell a good story with the data and not battle between being technical and not being too technical so the story can flow. So it was a good experience. I learned a lot and I will improve my next presentation. Thank you.
All right, fantastic. Shalaja, tell us what you did before Colaberry and tell us what it was like preparing for this presentation.
Yeah, sure. Before Colaberry, actually, I had a break in my career. Actually, I moved from other countries, so there was a break in my career. And Colaberry, it helped me to rekindle my interest, and they gave me the opportunity to explore. And like, it was a great platform for the learners. Like, you can expertise your skill, you can play with whatever you want, data science, SQL, all that stuff. And yes, it made me a better person, both in my career and developing my personality.
Abel, congratulations. Why don't you tell us what you did before Colaberry and how was it preparing for this presentation?
Before Colaberry, I was a high school graduate. So I graduated high school and just joined Colaberry. So I've been in Colaberry for 1 year and I graduated high school 1.5 years ago. So joining Colaberry was through my dad and preparing for this presentation. As I always say, my teammates are always there. That's Zayab, Shiny, Helen, and Davion. Those people, I could not do this without them. So I really want to thank those people. And preparing for this was kind of tough, trying to find a balance between telling a story, but at the same time trying to showcase. My whole project was kind of tough. Yeah. So thank you.
All right, awesome. All right, there you have it, guys. Congratulations, good job. Jeff, you have any final feedback?
I think generally, if you can think of a presentation, I like to think of two parts. There's the regular part and the detailed part. And just because I'm in this business and detail oriented, I tend to go through and create the full detailed presentation. And then I always go back after I've done all this stuff and I create a quick executive summary. And so what I think makes a good executive summary is I can read it on my iPhone without scrolling. 2 to 5 bullets on a phone, no scrolling, that's it. And when you're thinking about a presentation, take your whole presentation the same way. It's that thing, and then take your summary, put it at the beginning, and then put it at the end. And so that makes a good conclusion. So that way, if somebody comes in, they see the beginning of your presentation or the beginning of your email, which essentially is a presentation, they can look at the top, get the four main points and move on. And your detail-oriented people can go and get the supporting evidence. It feeds both types of audience, both a technical and a non-technical audience. If you have the details and the quick 2 to 5 bullet summary, that's for emails, for presentations, and for really any communication that you have. So thank you very much. Oh, maybe one more point.
Yeah.
Try to explain it like it was to your mom. Like, that's your executive summary. Non-technical folks should understand it. We should have data to help make these healthcare decisions rather than, putting your finger in and seeing which way the wind's blowing and guessing. So, all right. Thank you very much. Great job, all.
Robert?
Thank you.
Yeah. So to everyone, great. It was a good job. I know we had a winner. We don't have the others are not winners. You're all winners. You all did a good job. So please take that away with you. There were just some things we like more about one than maybe the other, but everyone has constant feedback about presentation skills. I get it all the time. I've been doing this for 20 plus years. I keep getting sent off to another communication thing. I'm the same as Jeff. I'll write a 150 slide presentation. By Monday morning, it'll be down to 3 or 4 slides. All right. What I recommend all of you do, go on Google, on YouTube, and search. And I think if you use these keywords, present like McKinsey or present like a consultant for McKinsey. There's, I can't remember, I'll dig the stuff out and send it to Sal later, the actual video. But there is a person that does presentations, and he shows you how people like Bain, McKinsey, and such like, they do their presentations, and it's exactly what Jeff talked about. One summary slide, and then 1, 2, 3 slides, top line, some detail, top line, some detail, you're done. Anything else, we can talk about afterwards. And you don't want to give too much, because you want them to come and talk to you afterwards. If you've given everything out, if I sit here and give you a presentation for the next 4 hours, give everything out, one, you're going to be too tired to come and talk to me, and you're not going to not be able to ask all those additional questions. But 2, you're going to get fed up with me and you don't want to know. Okay, so just think of those things through. On the data science side, I'm really, really excited what you're going to do with data science. I'll really focus this through, and for everyone, this is what's coming through. Whether you're doing data science, analytics, doesn't matter. Please do a history check. Just go and look up some stuff around what's going on. Reach out, go and look up on LinkedIn and see who's in the industry. See if someone's in your group that's in an industry, or one of the previous judges. Ping them and ask them, you know, oh, you ever worked in this industry? Can you give me some advice about what to do? There is a lot more data out there. This is always the problem with data. There's more data out there than we realize. And everyone says there's not enough data. There is actually a lot more data than we realize. We just need to find it and know where it is. I'm lucky enough on the Seattle one. I've been in and out of the Seattle one a lot, and actually all the states for that type of data. So I come across it. But there are some things, like on the med stuff I did while I was listening. I literally, within 10 seconds, I can find that information. Google is your friend. So please, 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 when you're going through presentations, especially when you try to formulate a hypothesis, there's nothing wrong. It's not cheating. You're not cheating. Go off. And by the way, we have a thing now called ChatGPT, or large language models. Use them. Just type the question in and see what it comes back with. It may be garbage, and you may be able to say, you know what? I went on ChatGPT 3.5 the other day, and I searched this. This is the answer. Well, I can tell you from my analysis, they're not right, because they quoted this and I've quoted something else. Okay, so those sorts of things, do those things, and it really will help open up your eyes. Colaberry are doing a really great job of getting you educated, but they can't give you a 2-year MBA, 1 to 18 months masters, and all these other things that some of us have done, and condense that down into a 10-week program. They're doing a really good job to give you a piece of it. But even when you've done those things, I done my master's many, many years ago, and I'm still learning now. If you actually could show you what's on my screen, I have a learning list of all the things I'm redoing and rechecking. There's a whole ton of data science stuff, stuff my kids come in and ask me, Dad, can you help us with? And I'm going back, oh, how do I do that? And I'm always constantly relearning. Remember, things are getting better. I spent 4 months this summer doing nothing but large language models and working through those. I can tell you all the theory, I can actually run the queries, but I spent time getting my hands dirty and doing it. There's no substitute for that sort of stuff. So practice, 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 and you'll be great. Okay. All 3 of you, well done. Thank you. I really enjoyed tonight.
All
Thank
right,
you.
Robert and Jeff, man, we really appreciate all your insight, all your value. Like, we don't underestimate this. This is very, very valuable to hear feedback, to listen to the presentations, to hear you guys' feedback, so everyone can improve. And everyone's listening to this feedback. It's not just about the contestants, but we have so many people that are going through this program just wondering what it's like when you get towards the end, wondering how they sound, wondering what's the feedback, wondering what their presentation is going to be on. So we thank you guys from the bottom of our heart. All right, well, guys, this concludes our Data Talent Showcase. Again, last one of the year. We will be back fresh next year, January, last Thursday of the month. So make sure you join us then. We are out. Thank you for joining. This has been another Data Talent Showcase. I'll see you guys next time.